Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Saqif bin Muzamir and my metric number is 211362713. In this video, we will discuss about lab 1. In this lab, it consists with section A and section B. For section A is Introduction to Simulink MATLAB and section B for Open Loop Characteristic. Okay, so we are going to use Simulink software. So open the MATLAB software and put the Simulink and press enter. Okay, so when the Simulink appears like this, we choose the blank model. So while it's loading, so we look at for section A lab. So the task is draw a model consists of 3 blocks, which is step, transfer function, and scope. So we must put the 3 O's of the block into this diagram. Okay, so we double click at the and we type the step. Okay, so we find the transfer function. Okay, so and the last we need to put the scope. Okay, so we put the arrow. Okay, and double click at step. Okay, so for the step time is 0. Click apply and okay. So for transfer function, for the initial output, we put the 0 and also apply and okay. So we run the block diagram. Okay, so the for scope. Okay, so this is output for the task. So we are gonna do 2.6 for this task, and we will change the transfer function for numerator and denominator. So for numerator is 9, denominator is 129. So click apply. Okay. So we run. So click for the scope, and so this is output for 2.6a, and for the b, the numerator is 625, and 10625. We apply. Okay. So run the system and click for scope for the output waveform. So this output for 2.6b, and for the c, the numerator is 10, 2, 3, 5. Click apply. Okay. So run the system. So and double click at the scope. Okay, so for 2.6c, the graph will be like this. Same with the task procedure. Okay, so we move to the section B for the first order system. Okay, so we can see at the procedure, it has a 3 input, which is unit step, unit impulse, and unit ramp. So for 3.1a, we have a key which is value is 2.5. For the tau, we have a 3 value, 1, 10, and 50. So we copy the transfer function. Okay, so since we have a 3 value of tau, so the transfer function also must be a 3. So we copy and paste it. Okay, so we put the value for first. The key is 2.5, and for the first stop is 1. Apply. Okay. So the 4-second transfer function 2.5, and the second top value is 10. Apply. Okay. So for the transfer function, the value of tau is 50. Click apply. Okay. Okay. So we have a transfer function. So we must put a component that's called is max. So since we have a 3 transfer function, we must change it to 3. Apply. Okay. Okay, so click run. Okay, so double click Xcode. So for the first order system 3.1a, the output will sound like this. Okay, so for B, we have a value 3 value of k, which is 1, 2.5, and 6.82. For the tau value is same. Okay, so for A, this is a unit step. Okay, so it's a unit step. Change to the unit RAM, so we can delete this and find the RAM. Okay, so put the arrow and click run. Okay, so double click Xcode. So this is with a unit RAM for 3.1a. Okay, so for unit impulse we do not have, so we must put a derivative. Okay, so and this we can delete and find the step unit like first. Okay, so for the value is 1, and for the derivative constant we put 1000, apply. Okay, for the unit step 1 we will change to the 0, apply, and okay. So click the run. Okay, so we run the system and click at the scope. Okay, so this waveform is for input impulse for 3.1a. So the procedure is same for 3.1b. So we change the value, which is k is 1, tau is 10. So the second one is okay, and this 6.82. Okay, so we run the system and click at the scope. So this is the waveform for the impulse unit for B. Oh, mistake. I'm so sorry. So this is not 50. This is 10 because tau is the same. So we click run again. Okay, so click double scope. Okay, so this is the impulse unit for the 3.1B. Okay, so this is the unit step output for 3.1B. And we find for a RAM. Okay, so we click run the system. Okay, so click double scope. Okay, so this is output for the RAM unit for 3.1B. Okay, so we are going to the 3.2. Okay, so for 3.2, since the transfer function only 1, so we can delete the rest. Okay, so for the value is 0.78 and 49, 7 and 1. Apply. Okay. Okay, so we'll find a derivative. Okay, so for this, we put value the 1 and this 100, apply. Okay, for this, we find a step. So the step time we will change to 0, apply. Okay, so we run the system. Okay, so click at the scope. Okay, so this is a output for the task 3.2 for the unit impulse. Well, for RAM is this one. Okay, so run the system. Okay, so the system is ready. We'll click for the output. Okay, so this output is for the unit RAM for the second order system. And the last one is unit step. So we'll change to the 0, apply, okay, and click run the system. Okay, so the system is ready. Click for the double scope. Okay, so this is a output waveform for the input step for the second system. For this task, I show only using the stop time is 10 seconds, but in my lab, I'm refer to the video instruction. I'm using the 100 second for stop time. So for the stop time, I'm using a 100 second. This will be like this, 3.2. This is okay. That's all from me. Thank you.